Torque is better known as rotational equivalent of force. It is the measure of the force can cause an object to rotate on an axis. It is also simply the tendency of a force to turn or twist. The straight line about which the object rotates is called axis of rotation, and the distance of the point of application of force from the axis of rotation is often called moment or lever arms. It can be either static or dynamic. Static is a type of torque that cannot produce an angular acceleration. Thus, dynamic is the one that produces a rotation within the acceleration. These are the examples. Number 1. Ronald pushing a closed door is applying a static torque because the door is not rotating despite the force applied. A man pedaling his cycle at a constant speed is also an example of static torque, as there was no acceleration. The drive shaft in a racing car acceleration from the original position or start line release dynamic torque because it must be producing an angular acceleration of the wheels, given the car is accelerating along the track. A simple way to calculate the magnitude of the torque is to first determine the lever arm and then multiply it times the applied force. From the above observation, I conclude that the torque produced depends on the magnitude of the force and perpendicular distance between points of application of force. So the formula for torque is equal to Fd cosine theta. The unit for torque is Newton meter or joule. Let's have an example. A 3-meter door was opened by force of 30 Newton and formed 86-degree angle from the initial position. Find the torque. Before I compute the problem, let's write the given first. The force from the given problem is 30 Newton. For the distance is 3 meters and 86 degrees is the angle, and then third is the required solution to the problem. And finally, let's write the solution. As I previously stated, the force in the given problem is 30 Newton. For the distance of 3 meters and the cosine is 86 degrees. And now, let's find the torque. 30 Newton is multiplied by 3 meter cosine 86 degrees. And the answer to the problem is 6.28 Newton meters. Now, let's move on to the next topic. Lever is a simple machine that consists of a stick, a beam, or a plane, and a balance point. It is also the most basic machines which are used to do some work with minimal effort. It amplifies an input force to provide a greater output force, which is said to provide leverage. We are aware that there are various types of levers depending upon the position of the fulcrum, the effort, and the load. The fixed point of the lever is called fulcrum. These are the three classes of lever. So the first one is effort, fulcrum, and load, or EFL. The second one is effort, load, and fulcrum, or better known as ELF. And the last one is load, effort, and the fulcrum, or LEF. This is a type of lever which has the fulcrum in between the load and the effort applied. This is the most basic type of lever. Here are the two examples. Number 1. Using scissors represents the use of two first-class levers. Number 2. Orlando's hand pushes a scissor or crowbar. In this type of lever, the fulcrum is at one end and the effort applied on the other end. The load is situated in the middle of these two. It would be called effort, load, fulcrum. The application of effort at one end will result in some work done on the other hand. Here are the examples. Number 1. Wheelbarrow. The second one is nail clippers, and the last but not the least is bottle opener. And the last but not the least is type 3 lever. These are the levers in which the fulcrum is at one end and the effort is applied in the middle and the load is on the other end. It is represented as a load, effort, fulcrum. In this case, we have to apply more energy to displace the load to a distance. These are the examples. The first one is baseball bat. The second one is broom. And the last is arrow. This is Jeric N Cascolan, a grade 10 life learner, and I want to say thank you for listening to the topic I taught earlier. I hope you enjoyed it and see you in the next school year. Bye!